We've all seen the picture. A single, infinitesimally small point of light, an unimaginable concentration of energy, containing everything that would ever become you, me, and every star in the sky, an event we call the Big Bang. This was the moment space began, the moment time started ticking. It's the first line in the story of our universe. But what if the Big Bang wasn't the beginning of everything? What if it was just the beginning of our chapter in a book that is infinitely old and infinitely long? This isn't just a philosophical idea, but the edge of modern cosmology, an idea that might solve the deepest mysteries of our existence. And it starts with a simple, childlike question that the standard model of the Big Bang can't really answer. What was there before? The standard answer is that the question itself is meaningless. It's like asking, what is north of the North Pole? The theory says you can't have a before if time itself hadn't been created yet. You can't have an outside if space itself was born in that single point. To be honest, that has always felt unsatisfying. It feels like a clever paradox, a loophole in language, not a physical reality. My intuition, and perhaps yours too, screams that you can't have a thing, all the matter and energy of the cosmos, without a place for that thing to be. So let's explore a different idea, an idea that is both more intuitive and in many ways even grander. What if space was not born in the Big Bang? What if space is eternal and infinite? An endless pre-existing stage, a silent, dark arena that has always been here and will always be here. In this picture, the Big Bang was not the creation of the stage itself. It was a local event. It was a moment, 13.8 billion years ago, in one tiny corner of this infinite expanse, when all the matter and energy that would eventually become our observable universe was concentrated into a single, unbelievably hot and dense state. It wasn't the beginning of space. It was the beginning of a storm within space. This simple shift in perspective beautifully solves all the bizarre, brain-breaking questions. What was before the Big Bang? An infinite expanse of quiescent space. What is our universe expanding into? More of that same infinite space. Suddenly, the picture feels more logical. It removes the need for a supernatural first cause and places the origin of our universe back into the realm of physics. But it opens up a new, even more profound question. If our Big Bang was just a local event in an eternal space, what's to stop it from happening again? The answer might be the most important law in all of physics, the second law of thermodynamics. This is the law of entropy. It states that any organized system will over time decay into a state of disorder and equilibrium. A hot cup of coffee will always cool down. A sandcastle will always crumble. An egg, once scrambled, will never unscramble itself. Our universe is doing the same. It started in a highly ordered, incredibly low entropy state, the Big Bang, and is constantly expanding and cooling, heading towards a final, dark, and featureless heat death where all the stars have burned out, all the black holes have evaporated, and all that's left is a thin, cold soup of scattered particles. This seems to be a one-way street, a story with a definite end, the ultimate triumph of disorder. But the second law has a secret. It is not an absolute, ironclad law like the speed of light. It is a probabilistic law. It is a law of overwhelming, mind-boggling odds. An egg will never unscramble itself because the number of ways its molecules can be arranged in a scrambled state is trillions of times greater than the one specific way they can be arranged in a whole state. It's not physically impossible, it's just so statistically unlikely that you would have to wait longer than the age of the universe to see it happen. But what happens when you have an infinite amount of time? In an infinite timeline, the unbelievably unlikely doesn't just become possible, it becomes a statistical certainty. Over truly unimaginable timescales, trillions upon trillions of years after our own universe has faded to black, random quantum fluctuations in the cold, dark void are not just possible, they are guaranteed. The universe is never truly perfectly still. There is always a faint quantum fizz, a constant rolling of the cosmic dice. And what could these fluctuations produce? A new particle, a new star? Yes. But given enough time, the ultimate lottery ticket will be drawn. A vast, random region of this dead, high-entropy space will defy the odds to reverse the flow, to recollapse back in on itself, recreating the hot, dense, highly ordered, low-entropy state that we call a Big Bang.
There is always a faint quantum fizz, a constant rolling of the cosmic dice. And what could these fluctuations produce? A new particle? A new star? Yes. But given enough time, the ultimate lottery ticket will be drawn. A spontaneous random fluctuation will cause a vast region of this dead, high-entropy space to defy the odds, to reverse the flow, to collapse back in on itself, recreating the hot, dense, highly ordered, low-entropy state that we call a Big Bang. This is the engine of cosmic rebirth. The Big Bang was not a one-time miracle at the beginning of time. It was a statistical inevitability in an eternal space. This paints a picture of a universe that is vastly grander than we ever imagined, an infinite, timeless ocean of space, and within it a constant simmering foam of universes being born and dying. Countless Big Bangs separated by unimaginable gulfs of space and time, each one a pocket universe with its own story, its own laws, its own potential for stars, galaxies, and perhaps life. Our universe is not the universe. It is just a universe. Our beginning was not the beginning. It was just the moment the cosmic dice landed on our number in our corner of the infinite void. This leads to the ultimate rejection of the idea that the universe simply popped into existence from a state of true, absolute nothingness. This is a logical impossibility. If there was ever a moment of absolute nothing, no space, no time, no matter, no energy, no laws, no potential, then that is all there could ever be. Nothingness does not have the property of becoming something. Therefore, existence itself must be eternal. There was never a beginning to existence, only a beginning to the current phase. This leads to the next logical step. If existence is eternal, what is the eternal thing? An eternal something else. This is the deistic or theological argument. The eternal thing was a creator, a deity, or a timeless consciousness that existed before time and space and initiated the Big Bang. This solves the problem and moves the question outside the realm of physics. The other option is an eternal physical reality, a fundamental aspect of the physical universe itself. The most logical candidates are space and time. In this model, an infinite, eternal space-time is the ultimate foundational is. It is the unchanging canvas upon which all the events of the cosmos play out. It did not need a beginning because it is the very framework of existence. The consequence would be an infinitely complex universe. This is the staggering implication. An eternal system with infinite time and space to operate has the potential for infinite complexity. What's clear, though, is that if this logical conclusion is right, the fact that the universe simply is eternally and is aware of itself through evolving life means that something truly extraordinary is happening with the universe. Our own existence is a tiny but meaningful part of its endless journey towards self discovery, literally. Thanks for watching.